Hi, my name is Anshu and welcome to my channel Bottleneck. This is a Scala design pattern series. In our previous video, we had discussed about type class. In this video, we are going to implement all the components of type class, ad hoc polymorphism and the magnet pattern. Alright, before we begin, I have created an app called type class and type class app config. I have integrated with the existing project. In our previous video, we have discussed how we can integrate a new app to the existing ongoing project. If you are not following along, you can refer back to the video and you can very easily able to integrate this. If not, no issues. You can directly use the code and run it over any app that you have and it is going to work perfectly fine. All right. Now, what is ad hoc polymorphism? Ad hoc polymorphism refers to the ability of a function or a method to operate on arguments of different types, depending on the specific implementation provided for each type. Ad hoc polymorphism enables a function or method to operate differently based on the input types. It is a powerful tool in functional programming, with type classes being a more idiomatic and flexible approach in Scala. Now, the different components of type class. First is we need to define a type class. So let's write a trait called show with type t. All right, and let's define an abstract method dev show, which will take a value of type t and it will return a string. All right, now we need to provide a concrete instance or implementation of the type class. So concrete implementation of the type class. All right, so we will bind it inside an object show. Okay, so we will write implicit val string show and it will return a show of type string. All right, so it will take a value as string and it is going to return a string. All right, input is $value. All right, similarly let's write couple of more implicit. Okay, let's name it as int show. Again it is going to return a show of type int. Okay, and the implementation would be more or less same. The only thing that is going to change in the type of value to int. All right, let's create one more implicit val sequence show. All right, this is going to return a show of sequence of int. Okay, now it will take a value that is going to be sequence of int, and this is the input is all right. So till now we have created defined a type and we have created an implementation, a concrete implementation of the type class. All right, so now the next thing is we need to call them somehow so that the entire hierarchy works together. All right, so now we are going to create a magnet. So magnet, basically, as we had defined earlier, that based on the type of input provided, the implicit will be called. So let's define the magnet. So it is going to be show of type t and it will take a value of type t. All right, and it will also take an implicit of type of show of t. Okay, and it is going to return a string. All right, and the implementation would be ev dot show and we are going to pass the value. Now, whenever we are going to call a show with some value which is defined as an implicit which returns a type of show, definitely this is going to call upon based on the implicits and accordingly it is going to process. All right. So let's see how it works. Let's call it here. Okay. So let's call the show with say a value, say Scala. Okay, this is a string. Now let's call again a show with say a value 2025. All right, now let's do one more println and let's call the show with a sequence of 1 comma 2 comma 3. All right, so we have three different values calling upon show, and this is this is a magnet, and entire hierarchy that we see is an ad hoc polymorphism. Here as we see, this is the implementation of polymorphism, that we are implementing multiple behaviors based on the type it is being called upon. All right, so let's run this and see whether we have achieved our goal or not. Okay. All right. So the advantage of using type classes first is the extensibility. You can add behavior for new types without modifying the 61. If you have more of shows, so you can add show for double without modifying any of these. So this will be more verbose, and anyone or a newcomer who looks into the code, he will be very easily able to understand what actually this means. The functional meaning will be intact. So this will make more sense if you talk about a validation scenario where you are doing validation on various measures, and you can bind everything inside our trait called validation, and you can have different implicit validation implemented, and you can have a validate magnet which will call upon, and based on the type of validation that you want, it will validate straight away given the input value. All right, so now this can also be useful while serializing your JSON. So if you have multiple different custom types that you need to serialize a JSON to, then you can implement this similarly. This pattern is widely used in libraries like cats and scals, and because of the type safety that we see. All right, so this is all about the type classes and ad hoc polymorphism and magnet pattern that we see with the type class. In the next video, we are going to talk about the variants and the different type of variants, and we will see the implementation of it. Alright, if you enjoyed this video, please like and subscribe, and see you in the next video. Thank you.